teaching you physics for the target to become IITian, become to qualify in top rank of the NEET, and you can score very good marks in the Cbse also. So I cover entire course from the today last two I class taken live on the YouTube. So from the today we can say the entire course is finished in the December month, and thereafter you go for the mini test in between the class, after the class, for the Cbse, for the NEET, for the IIT-JEE main and advance. And after the finishing, we take small classes to revise the entire physics. Thank you. In the last class, you have studied that force is equal to del upon dt, and in the last class mass is not here, mass is here, which was constant. Today I am putting it that V is constant and mass changes with the time. You can think, what are the examples? One is rocket system, second is water of your tank on the roof. So the water flowing in the rivers, the Ganga, you know. So water in the tank changes mass if you tap and you use water in the life for the bathing, for the drinking, for the various work. Again, water of the river like the Ganga, Amazon, like that, all is used to produce electricity. In that case also mass of the flowing water changes. So such a application where mass changes and velocity of the water flow remains what? Constant. From the any source, flow of water may be constant. So when velocity is constant, then mass may be changes. So such situation is also be applied in the life. You have seen, I have discussed with you. Today we discuss about the impulse you have seen, and there is also what? Impulsive force. So what is impulse? And impulsive force, we see that. we explain about it. There is a body having certain mass or a particle moving in a straight line. You know there is force m into a if it is in the motion. So I like to see the changes in this force in a graph. There is force, there is a time. So when time is very small, force is like that. Here force reaches the maximum, and again time t is here, but there is also very small force. There is small force, there is more force, there is, you can say, maximum force, and again force changes. So there is a small force, you can say df, there is a small time, you can say dt, and in the entire journey from 0 to t time period, this is the actual graph of the entire journey, role of the force with a certain time. So there is what? I want to know about the force. So I am writing here average value of force. You can say this is impulsive force. So how can you calculate the average value of the impulsive force? So you know area of this graph can indicate about the impulsive force. So this is force average, or this is impulsive force. This is equal to what? There is integration of force into time in very small interval, and it is divided by the total time. So total time from 0 to t, this is given. So this is equal to, you can write f is what? F is change in momentum upon dt. There is also dt. This is what? Total time t. You can see here area of this graph is given by the force. So you can also tell average force into time, total time, is equal to what? dt is cancelled. So what there is? Change in momentum. There is what? Change in momentum. There is what? Force average into time. What is change in momentum? You can write here mv minus mu upon what? T. This is equal to what? force average, which is called impulsive force, and this is force, this is time, gives the area of this graph, and there is what? Impulsive force. So this is the value of what? Impulsive force. Correct. Again, if we write here force into average, force average into time, this is equal to what? Changing momentum. And this changing momentum, F into t, this is called for impulse. So impulse is here, I is equal to average force into time. You can ask me any example of this impulse. Impulse is basically changing momentum. So this is equal to what? You can say impulse is equal to changing momentum. Example, I am telling you that suppose you are in the road and a bike crosses their foot, and the wheel of the bike for the few seconds on your foot. So what will happen? There is no damage in your foot, because bike or weight was for the few seconds, not for the more time. So their impact is very small. Tomorrow in the class, I told that if you apply thappad on this part, so hand is for very small time in contact of this part. So this is also what? Impulse, force acting for the small time interval. Again, we discussed many things about the impulsive force and the impulse today. I am telling about the application. In your life, suppose a person of weight 60 kg is running, jumping like that and come on the ground. So I am telling about the sports person. So when come on the ground, what will happen? This is the ground. After jumping, come here. So what happens? When it come here, final velocity becomes what? 0. But before the striking, there is more velocity before strike on the ground. So I write here that impulsive force, average force, mv minus mu upon total time. So final velocity becomes what? 0. A mass of the person is 60 kg. initial velocity before the strike is suppose 40 meter per second. 40 meter per second before the striking on the ground. So how much time taken it when it strike the and velocity becomes 0? There is total time is suppose half second. You can say 0.5 second. So there is time available is only 0.5 second. So what happened? It will be 48,000 Newton is force applied here when velocity becomes what? 0. Now how much this amount when this person move in the water, same suppose person go to the water, then what happened? Same sports person fall down here and there is what? Water present in this. There is a water. Here, suppose on the surface, how much is the velocity? And it take more time to reach here. 2 second time. Same as sport person jump inside the water. There is water on the ground, and it take to become velocity 0. Take time what? 2 seconds. In the same equation, what happens? The impulsive force that is equal to 0 minus 60 into 40 upon time is what? 2 seconds. What happens there? Its force decrease. How much decrease? There is 20. So 60 into 12 Newton is their force. Here is 4,800 Newton. Here is 12,000 Newton. In this case, you can consider this is equal to mass into G. So there is mass how much? Mass is here 120 kg into 10. Here is mass how much? There is 480 kg into G. So there is weight is small, force is small, there is more force acting on the body. Similarly, I am changing this situation. For the same person, there is not water, there is a sponge matter. A sponge matter, or like sand. You can also say sand. So when it strike, it go to here and travel 5 seconds to come to the final velocity 0. In this case, what is the average force or impulsive force? In this case, 0 minus 60 into 40 upon 5 seconds. So this is 12. Their force becomes how much? again 48 0 Newton. This is equal to how much? Mass is 48 kg. 48 kg into G. G is, you know, 10 meter per second square. In place of 9.8 meter per second square, I am taking here 10 meter per second square. So there is this person can easily survive. This person also try to survive in the water, but on the ground there is force 48,000 Newton. That is very difficult to survive the person on the ground. If you play cricket, second habit of the life, cricket player. If the player receive the ball in hand, in the catch, and it take very small time, 0.01 second, what will happen? You capture the ball. This is suppose the ball. I capture the ball and take very small time, that is 0.1 second. So this ball has mass suppose 0.5 kilogram. There is mass of the ball is 0.5 kilogram. So what will happen? There is average force is equal to 0 minus 0.5 into suppose 60 meter per second. This velocity is how much? 60 meter per second come in the hand, and it take how much time? 0.1 second. How much is force here? This becomes decimal is there is 10, 30, 3,000 Newton is force here. But you catch the ball and move the hand below, and this takes suppose 2 second time. So if your hand is coming down and time taken here is suppose 2 seconds, there is mass how much? 300 kg into G. G is what? 10. Now it's become what? For the 2 second time, this become 0.5 into 60 upon 2. This is how much? 30. This is equal to this comes here 10 30, this is equal to 50 Newton, that is equal to 1.5 kg into G. So catching of the ball also impulse force is applied in that case. So the general is application in the life you are using. So physics is, I think, very simple, that can see without the laboratory. without the very high expenditure. Again, glass packing. You have purchased many glasses and you have found that glasses is packed by the paper. So there is suppose the glass 1, there is suppose glass 2. There is of this glass 2, this is glass 1. There is no velocity. Initial velocity is here, u. When the carrying truck carrying the vehicle moving forward, then this glass go to this point and their velocity becomes what? 10 meter per second from the zero. Initial velocity 0. So what will happen here? Here is force again. Mass of glass is suppose 0.25 gram. So there is 0.25 gram is mass of the glass into 10, and time taken is very small. Suppose 0.1 second is time taken here, very small time. So what will happen here? This becomes 10. There is 100. Decimal is cancelled 10. So this is cancelled out. There is 25 Newton force. So when the 25 Newton force applied between the two glass of the made of glass also, what will happen? Both strike and jerk is created here and destroy both the glass. So if you are packing two glasses, glass 1 and glass 2, glass 1 and glass 2 is packed by the paper, then it take more time, suppose 2 seconds in the collision. So in this case, how much force act here? There is velocity, mass is 0.25 kg, velocity is 10 meter per second, time taken is 2 seconds. In this case, this becomes what? 5 and decimal goes, this becomes 100. So 4. This becomes force 1 point something. So there is less force, 1 point something. So there is more force, more jerk. So do you know jerk? Yes. In the motion in a straight line, jerk is basically vector quantity, that is change in acceleration upon time or change in time. This is called what? Jerk in the physics. In the higher studies, like in the IIT, you can study details about the jerk. But this is the foundation of the impulse and impulsive force. So impulse is what? Force into time. Impulse is average force into time. This is impulse, you know. And this is also what? Impulse is changing momentum. And you know, average force is what? Average force is delta P upon T, time taken. So when time reduce, when time decrease, the impulsive force increase. But if time increase, then impulsive force decrease. So impulsive force F is here is proportional to the time. So time increases, then impulsive force decreases. Time increase, time increase, time increase, then impulsive force decrease. Thank you very much. In the next class, we will study about the conservation of linear momentum of the straight line. Thank you very much.